Hello everybody, welcome back. Today we're going to be talking about latches and flip-flops, and this is when we start to get into kind of the time domain when we think about all this digital logic that we've been working on. We've had AND gates, OR gates, all this digital logic, K-maps, the whole gambit, and now we're trying to think about, well, how do I save the state for our logic over time? Let's say maybe we want to be able to do some logic and then go from one state in our program or one state in our circuit to some other state. And to do that, we're going to need some sort of a memory element. And today we're going to be talking about a whole bunch of different memory elements, and I'm hopefully going to be able to walk you through them. But at the fundamental level, we are going to start with latches and flip-flops. And to do this, the first thing that I want to make sure you guys know before we kind of get into the rest of this is to think about the function over memorizing the details. So think about function. Okay? Think about the function over everything else. Because if you can understand the function of these memory elements, all the rest of it's going to come naturally. Okay? So when we think about the function, what this means is likely it has to do with, we said, memory elements. Memory elements are used to store data for overtime, right? Sometimes we need to store data. And so we need to think about the functionality of what it means to store that data. And once we start getting into the details of the first one, it'll start to make a bit more sense. So the first thing we're going to look at is a latch. So we'll write that out here. So I'm just going to make that. This is a big note. We're going to try and remember this throughout the whole video. Think about function. So first off, the latch. Okay. What is the function of the latch? The function of the latch is on the active clock level. Okay, active clock level. We store the data. Store data. On the inactive clock, level, sorry about my spelling, we are going to hold the data. Right? So again, functionality over everything else. When we think back to how we were learning AND gates, it was probably first thing was, here's the truth table. This is going to be the opposite direction. I'm actually going to end with the truth table. And we're going to see if maybe we can start to understand what's happening there. So we think about it, function first, everything else comes from that. So the functionality here, on an active clock level, so we're going to have some sort of a clock signal probably in this element, this piece of memory. There's going to be a clock signal and some data, and then probably an output, right? In fact, why don't we just draw what our latch looks like from a schematic perspective, right? So I'm going to draw it here. We're going to have a D, right, which is our input. We're going to have the clock. And actually, let me make sure I draw this just right. You'll notice I drew a little arrow in there. That's because I'm getting ahead of myself. There is no arrow here. We're just immediately going to have clock. Then we're going to have Q and Q negated. Those are going to be our outputs. For all of these elements, we're going to have the output, because there's 1-bit outputs, and we're also just always going to have the inversion of it. It's more important later on to have those inversions, and it's nice to just have them there when we start connecting things together. But for right now, just know that there is the output and then the invert of the output, Q and Q negated. And this is our latch. This is how we would draw it. And so we are going to think about, well, we said latches, there's an active clock level. So what if we just draw out a clock signal, just kind of a sample clock signal? I'll make it nice and long. So here's our clock. Let's say let's change our color up a little bit. We'll go blue for this, right? And so it starts at 0, right? And then we'll say it goes up, right? Our clock is gonna, I'll do every 2 we kind of cycle back and forth. just to show. And this is kind of, if we think about when we start wiring up a circuit, right? There's going to be some sort of square wave. Typically, all these circuits are 0 to 5 volts. And so I can write that here as well, 0 and 5 volts, right? We can write that there. So when we think about active clock level, it means we're thinking about the different levels that this has, right? So let me change the color again so we can see this, right? So here we have the pause level, the positive level. And as an example, if we go way over here, we have the negative level, right? So we have two different levels. We have the positive level, 5 volts, logical 1, right? True, right? All of these things are interchangeable words in some sense, right? At least in the topic that we're talking about here. Trying to get the active clock. There's two options, right? We could say the clock is active on the positive level, or we can say it's active on the negative level. And so for this example, we're going to switch right back to our normal pen color. We're going to say positive level D latch. Okay, so this example we're going to do is going to be the positive level. Okay, so we have our clock signal. Now both of these over here, right, are inputs. And then these Qs are going to be our outputs. So we're going to give a sample D as well. So let's just draw out a nice long line for D. And I'm going to just draw a random signal for it. We'll say we go up here. And we'll keep it up. We'll keep it up. And then we'll have it go down here. And we'll keep it low for the rest of it. This could be any random signal, right? This could be coming from somewhere else in our circuit. Or maybe this is us manually connecting D low and then connecting it high, right? So we have our two signals, clock and D. And so I'm going to draw out Q. I'm just going to kind of give it the baseline for kind of where we're going to draw it later. And then I'm going to start to understand how the functionality plays into this. So to think about it, we said two things. We said this is a positive level D latch. That means the active clock level is the positive level. And so for this next part, what I'm going to do is I'm going to label all of the different parts. So notice how I'm kind of breaking it up by high level, low level. It's because now I can just write, this is where we are going to store data, right? For all of the positive levels, we're going to store, right? Way over on the edge. And everywhere else, all the negative levels, the inactive clocks for this example, we're going to hold. So we hold, we hold, we hold, and we hold, right? So for this period of time, right, we're going to hold. Then we store, which means we'll copy the data. We'll take whatever data is in D and store it into our memory element. That'll make it the output. Then we hold it. Then we store again, and we hold again. And in fact, for this example, just so you guys can make kind of a bigger point, later on I'm going to do something a little tricky here, and you'll see why. Right? We're holding, so that means we probably won't be storing this change in data that happens here. Okay? But we'll see that as we go on. So we start off by holding, and I'm just going to give you guys, you'll normally get like a starting Q value for all of this kind of beginner stuff that we're going to go through here. So we say we're holding for this whole time period. So that means it's not changing for this whole time period. I don't even need to think about drawing Q for this whole time period. What I have to start thinking about drawing Q is that during the hold, we just match it. So whatever D is during the store, we are going to store that as Q, right? So it's a pure match, right? So I'm just going to draw that little arrow there so you can see. We just copy it right down. For the hold, we take whatever value we have, right? And we hold it for that entire period. So I'm just going to hold it all the way across. When we get to the next store, we take whatever is up here and just copy it down. So we get to the next store and we store it in. Now, in this example, it just happens to keep holding it, you know, at this one value, but we are storing this one for the entire duration here. Now the next step, this is why I wanted to be a little tricky with you guys. What you see here is we're holding, which means we don't care about what's happening here with D, because all we do is we hold whatever value Q is and hold it across. Notice how we're kind of skipping over this little divot in D where it goes down and back up, because all of it happens during the store. Sorry, it happens during the hold, right? The hold holds the Q value. It doesn't care about what D is anymore. This entire section where we have the negative level, which is the inactive clock level, right? The inactive clock, we hold our data, which means we take our value and we hold it for the entire negative edge. Sorry, negative clock. And so we're going to continue going on. What happens when we store? When we store, we take whatever's here and we just copy it right down. Right? What happens when we hold? We hold the data across. Doesn't matter what D is. We take whatever we ended with and hold it for that period. Then we have another store. So that means we take whatever is here and we bring it down. In this case, we're just kind of getting to the end of our example. Now notice here, what's going on? We started off by holding what we had. Then we copy in exactly whatever D is. That's the storing the data. That's the storing the data that we have here. And why are we storing it at this section here? It's because that is the active clock level. We store during the active clock level, right? And so we've actually gone and drawn an entire timing diagram without thinking about the truth table. And that's what I want you guys to think about to begin with, which is don't think about truth tables as your golden rule and going from there. If you can understand and remember the functionality first, the truth table comes from that. You can use the truth table as a reference, and maybe that'll help you more. Maybe that'll make it a little easier for you when you come to trying to draw these timing diagrams. But I want you guys to understand functionality first. And so now we're going to end by writing out this D-latch truth table. We have clock, right? We have two inputs, clock and D. And then we have the Q of, actually, I'm going to write clock, D, function, and then Q of T plus DT, right? It's Q of some small next time step. So when the clock is, we're going to do the inactive one first. When the clock is inactive, so this is pause level, right? When the clock is inactive, what does that mean for a positive level D-latch? The inactive clock is the negative level, right? The positive tells you the active. In this case, we said positive, so that means that that's the active side is positive, and that means the 0, the low, is inactive, right? And we've already said that's holding the data. We hold it, right? And it doesn't matter what D is, because our Q of T, right? I'm just gonna kind of separate it out a little bit. Our Q, the next step, right? This Q of T plus delta T, that means the next step is just whatever the previous step was, right? When we're in this section here, right? The Q is the same from step to step, right? It's the same at this step, to 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 this step, right? It remains the same at each little step. It doesn't matter what's happening with D. And right, that's when it's most true over here, right? Because D might be changing, but it doesn't matter. If we're in the hold state, in the hold functionality that's going on over here, because we have the inactive clock, then it doesn't matter what D is doing. We The next step is the same as the previous. The next step is the same as the previous, all the way across. So that's the hold function. That's the first half. The second half, all right, we have 0. Sorry. Second half is the active clock. So what does that mean in terms of what level it should be? That means it's positive because we said this is a positive level D latch. So the active clock is 1. We have 2 options for D, right? It can be 0 and 1. And the function is store for both of these. We store the data. And that means when D is 0, then Q is 0. When D is 1, Q is 1. The other way we could be writing this, okay? Sorry, I'm scrolling down a little bit. We can write clock D, and I'm just going to start simplifying this a little bit. Delta T, right? Same thing, we can write DT delta T. We can simplify this a little bit by, we had this truth table before. We can get rid of this D column, right? And watch this, watch this. So we said it's positive level. So clock is 0. Our output stays the same, right? If clock is 1, the output is just D. Capital D there, meaning D is our input. So right now, we've always been talking about a positive level. I want you guys to take a second. We're going to draw, I'm going to write out the truth table. I'm just going to give you kind of the overview, right? This kind of simplified form. I want you to pause the video right now and think about what negative level truth table would mean. A negative level D latch. So I'm going to scroll up a little bit, see if we can get the definitions back on the screen. Scroll up a little more. So D latch, the active clock is store, inactive clock is hold. I want you guys to try and fill in, pause the video now and fill in this negative level truth table. Okay, hopefully you were able to start getting through that. I'm going to start filling it in, which is we have 0 and 1 for our clock, right? And essentially what we're doing is we're just going to flip the 2 things we had previously. So we had the functionality here, which I'm just going to throw on the end. Functionality. Now the 0 becomes our store. And the 1 becomes our hold. And now it's the same idea. We started with the function. So now we can think, oh, hold function is easy. That just means it stays whatever it was at the previous step. And the store function is also easy. That just means we take whatever D is and that becomes our output, right? And so that's how you could use this. Kind of, we started always thinking about the positive edge, but we also have to always consider about this negative level, the negative level. Okay. I hope you guys enjoyed the video. There's going to be links in the description to even more practice, including just a bunch of timing diagrams and a bunch of open kind of truth tables and stuff for you guys to fill out, including separate documents for solutions. So go ahead and look in the description for more content. Hope to see you guys in the next one.